Hi there, everybody. This lesson is about law of sines. I may not know what that is yet, but you soon will. Um, we have lots of tools for finding missing sides and angles in right triangles. We've got Pythagorean theorem, sine, cosine, and tangent, and special right triangles to find missing sides. We've got inverse sine, cosine, and tangent to find missing angles. We also know the angles in a triangle have to add up to 180. But none of those will work for triangles that are not right triangles, triangles without a right angle. So we're going to look at that a little more closely here. So here we got a triangle ABC. I've labeled two of the sides. The side opposite angle A is little a. The side opposite angle B is little b. And I'm going to draw the height in here. Call it H. If we knew what angle A and the side B was, we could find H. H is opposite this angle, and B would be the hypotenuse of this left side, this right triangle on the left over here. So opposite and hypotenuse is sine. So we could write an equation with sine. Sine of A equals the opposite side, H, over the hypotenuse. And we could do the same thing over here if we knew angle B and this side A. Again, H is the opposite side to B, and A is the hypotenuse. So we'd have the sine of B equals the opposite side, H, over the hypotenuse, A. Now they both have H's in these equations. Let's solve these equations for H and see what happens. So we got H equals B, little b, times the sine of angle A. And doing that over here gives us, those A's cancel just like those B's did, and we get H equals A times the sine of B. So really that's just two different ways to find the height of this triangle. They both should give us the same answer. So that means that B times the sine of A should be A, little a, times the sine of B. They should give you the same thing. Now, I'm going to divide both sides here by little a, little b. And those a's cancel, these b's cancel. And what we get is sine of a over little a equals sine of b over big B. And this is the law of sines. And we can use this equation to find missing sides in triangles, whether they're right or not. Actually, they do work for right triangles. This does work for right triangles. It works for triangles that are not right as well. So let's take a look at an example here. Here we've got a triangle. Let's call this one 26 degrees. This one is 42 degrees. Let's say this side is 4 and this side is x. Now the thing about the law of sines, this is an angle and this is a side. And this angle and this side, they have to be opposite each other in the triangle. So here's angle A in our original picture. The side opposite that is little a. Those two in the equation have to be opposite each other. Same thing with the angle B and side B. Those two have to be opposite each other. Well, 26 degrees and 4 are opposite each other. So we have sine of 26 degrees over 4. And the 42 degrees and the x are also opposite each other. So we'll put sine of 42 degrees over x. Now we've got an equation that we can solve. So let's get our handy calculator here and see what this thing tells us. So we need to know what the sine of 26 is. So in mine, I've got to hit 26 and then sine. It may be a little different in yours. So we got 0.438 over 4 equals. And then we need to know the sine of 42 also. So 42 sine 0.669 over x. Now I've used 3 digits for each one of those. That's a safe way to go. Use at least 3. If you can use more, if you can figure out a way to use more easily, do it. But at least use 3 digits. Now we just cross multiply. 0.438 times x, and then 4 times 0.669. That's 2.676. Then divide by 0.438. And we get x equals, let's see, divided by 0.438 equals, it's about 6.1. I'm going to round my answer to the nearest tenth. That's okay. There is that missing side in a non-right triangle. Let's try another one here. So this one's a right triangle, and we have easier ways to do this. We could have just used regular old sine on this one, but law of sines will work here as well. So the 90 degrees and the x are opposite each other. So let's do sine of 90 degrees and x. And the 52 degrees and the 8 are opposite each other. So sine of 52 degrees over 8. And now we've got our equation. Let's see, the sine of 90, I've taken a few more math courses than geometry, so I know that's 1. If you don't believe me, let's check it out. 90 sine, oh, there it is, 1. So 1 over x. We need the sine of 52. So 52 sine, that's 0.788, and we still have 8 on the bottom. Now we cross multiply. 8 times 1 is 8. We got 0.788x. Divide by both sides by 0.788. And we get x is about, let's see, what do I want to do? 8 divided by 0.788. And we get x is about 10.2. There we go. And if you used sine, regular old sine, sine of 52 equals 8 over x, like we have been in the past for right triangles, you will get the exact same answer. So let's do one more. Say this angle is 120 degrees. This side is x. This side is 10. And let's make this one 32 degrees. Now go ahead and pause the video and give this one a try on your own. 120 degrees and the x are opposite each other. So we got to have sine of 120 degrees over x. But the 32 and the 10 are not opposite each other. 10 is the only other side we have, so it has to go on the bottom. But the angle that's on top has to be opposite the 10, and that's this one, which we don't have. Now, fortunately, we do have the other two, so we can take these two away from 180 to get this one that's missing. Let's see, 120 and 32 is 152. Subtract that from 180, and you get 28 degrees. So we should have the sine of 28 degrees on top of that fraction. Remember, this angle and this side have to be opposite each other. And same with these two. So let's see here what we get. Let's see, 120 sine is 0.866. It's still over x. Sine of 28 is 0.469. And that's still over 10. We cross multiply, we get 0.469x equals 8.66. That's 10 times 0.866. Divide both sides by 0.469. We get x is about, let's see, 8.66 divided by 0.469. X is about 18.5. There we go. There are 3 examples for the law of sines. Hope that makes sense. We'll talk to you soon. Have a great day.